Harris, who I think you know, who's at the LPL.
Oh,
I had asked Dante Loretta, but he was busy doing, 9 missions simultaneously. So he suggested Walt Harris, and I mentioned what was going to be in the issue to Walt, and he said, "Oh yeah, I know David very well. Speaking of you." Yeah.
Walt Harris. Yeah. Well, thanks. Looking forward to this.
So I think it's going to be really nice.
Looking forward to it. And I haven't said a word.
Thank you. Yeah, I think it'll be really special. Yeah.
I didn't think that included Wendy.
Oh, well, Wendy has to know everything, of course. Yeah. That's part of the contract. Yeah.
Mm-hmm. And tomorrow we celebrate the 25th anniversary of that contract.
Wow, congratulations.
Thank you, David. 25 years. And we still love each other.
That is amazing. Well, we'll have to drink a toast to you tonight here.
Well, thank you. I shall drink a cup of coffee.
I'm drinking tea here. That's all I'm drinking. Yep.
Okay, during your presentation and during some others, you may just see my background without me, but I am here. I just have to move to a different spot for a little bit.
Yeah.
Someone's ringing the doorbell.
Mm-hmm. Makes me think of that Wings song, "Let 'Em In."
Yeah.
I was listening to Wings almost all week today.
Yeah,
I enjoyed those guys.
I saw them.
Hello, Terry.
Hi, Terry.
Hi.
Hi, Terry. It's good to see you.
It's good to see you too.
Terry, you must have like blasted through Fairbanks.
Yeah, I kind of did. I thought we were starting still at 8 o'clock Eastern. And so I was about an hour behind. So I had to run through McDonald's and get something to eat and get back out here. Yeah, the roads in town are great, but I'm staying about 40 minutes outside of town and they're pretty much a sheet of ice. But, I find my car that I rented slides very nicely down the road.
Well, I'm glad you made it okay.
Oh, yeah. Yep. It's beautiful here. A lot of snow, but beautiful.
Yeah, I like the image of the cabin or wherever it is that you're staying.
Yeah, I've rented a house. And let me see if I can show you out my backyard. They've had 92 inches of snow this year, this season.
We're gonna let the audience see what's going on.
Man, let me see if I can put this back on. But there is just snow everywhere. But like I said, it is absolutely beautiful. Let's see.
You got a really good internet connection up there.
Yeah, I'm really surprised. It's not really focusing very well. Can you see any of that?
No,
Better yet. Yeah, it's kind of a whole different world after being in Ohio.
Yeah, you had the out of focus filter on your Zoom, so it just looked like completely blurred. Oh, there it pops in and out sharply every once in a while, but
Yeah, it's just unbelievable. But anyway, it's very pretty. I haven't seen any moose yet.
okay. I like this particular quote by Steven Pinker. And I
Yeah,
didn't know
there's many
anything
quotes.
really about Steven Pinker until I read about him today. But
That's
so
a
he's
good
an
quotation.
author.
Yeah.
Yeah, he's a psychologist and an author. Must be interested in astronomy.
You know, even out here, I'm amazed. There has been aurora almost every night, but it is amazing the amount of people here. And when the aurora is out, if you're set up alongside the road or wherever taking pictures, so many people will stop and come up and want to look with you, you know, and just talk. It is really amazing
Hmm.
how many people, because I really believe the astronomical community has definitely grown during COVID.
Mm-hmm.
Oh yeah.
No doubt.
NASA's explorers on Mars are on the move and making new discoveries. It's a journey you can be a part of too. NASA's Curiosity rover, which has been climbing Mount Sharp since 2014, is about to drive up onto a broad, sloping surface called the Green Hue Pediment. This will allow scientists to fast forward perhaps millions of years in Mars's history and study the history of liquid water written into these different layers of rock. And Curiosity made some interesting discoveries along the way. Less than half an inch in size, this unusual feature, eroded from sedimentary rock, was cemented by mineral-rich groundwater. And check out this rock, smoothly eroded by winds. Over in Jezero Crater, the Perseverance rover is getting ready for a new destination and science campaign. And it's consistently setting driving records on Mars by relying more on self-driving software that allows the rover to avoid obstacles without having to consult a human on Earth. Perseverance will be pushing north in an area where an ancient river flowed into a body of water. It left sediments in a shape called a delta. The rover will collect more rock samples there. The Ingenuity Mars helicopter will support Perseverance's upcoming science campaign. The helicopter has been given the green light to try to keep flying on Mars for the next few months. Upgrades to its navigation software will improve flight and operational safety. The Mars explorers will document the journey along the way, and you can make your own discoveries. Visit the raw image pages to see the latest images every day, and vote for your favorites. To get the latest updates, follow @NASAJPL and @NASA Mars on social media, or take a deeper dive on the mission websites at mars.nasa.gov.
Well, hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance. And I'm back with all of our astronomers from around the world for the 87th Global Star Party, Cosmic Evolutions. And so it's always I always look forward to Tuesday nights because of the GSP. And, I'm glad that we've got a global audience watching this right now. And we can get started, but just to kind of recap who's going to be on tonight, we'll have David Levy will be on with us. Terry Mann is filling in with Chuck Allen. She's up in Alaska right now. If you couldn't catch some of the earlier behind the scenes part of our Global Star Party. So we're glad she's on with us tonight. And then we've got Dave Eichert. He'll be talking about minerals of our solar system. I think this time he's focusing on calcium. So Gary Palmer is with us tonight, which is great. Rodrigo Zelada from Chile, he's on with us as well. He hasn't been on for a while, so it's great to have him come back in. Dan Higgins with his co-host Eric Watson will be on with us from Astroworld TV. Russell Fralich from the Royal Astronomical Society of Canada will be on with us as well. He'll be discussing his experiences with teaching kids all things about space. So very, very interesting. He's all fired up about that. Molly Wakeling's coming on with us tonight as well. And then we're expecting Marcelo Souza and Maxi Falieres to kind of wind up the night for us. So I will transition over to David Levy. I promised myself I would talk a little bit about David Levy's book, his biography, which David can, he'll kindly hold up a copy of it, I would appreciate that. But David is an amazing individual, has contributed so much to education in astronomy, inspiring, people of all ages. If I go around in the astronomy circles around the world, I only have to mention the name David Levy, and of course, many people recognize him, know him from all of his contributions. But if you ever get a chance to meet the guy, he is an amazing friend and very grounded and very, someone you can ask him any question about astronomy, and he's always so interested to talk about it and to share his ideas with you. And he's going to do that with us tonight here on Global Star Party number 87. So, David, I'm going to transition over to you, but thank you so much again for coming on to Global Star Party.
Thank you, Scott. And here there is a copy of this book.
There it is.
It's kind of been we've kind of kept it a pretty good secret. I don't think too many people know about it, but it is available if you live anywhere in the world except in the United States. And even there, you can get it from the Royal Astronomical Society of Canada. Their website is don't forget the rasc.ca. But if you're in the United States, you can go to starizona.com and you can get it delivered from an American address, because Starizona does stock this book in the United States. Anyway, last time I took a little more time than usual because we had David Rossiter here singing that beautiful song about Vincent van Gogh. So tonight I'm going to come up with something a lot shorter. I can't believe that I did not catch this while I was working on my doctoral dissertation over at the Hebrew University. It's from A Midsummer Night's Dream. It's very short, and it takes place as Bottom is about to die, and they play within a play, I think, and just these few lines, and here it goes. My soul is in the sky, tongue lose thy light, moon take thy flight, my soul is in the sky. And now back to you, Scott Roberts.
Thank you very much. That was short, David. But sweet. But sweet. That's right. So David, what have you been watching in the sky recently? What's been capturing your interest?
Well, I went out last night to do some comet hunting. I did a 10th of an hour. And then I've been working on this lovely triple star that I've been following. It is Omicron. Omicron. Oh no, we all have to scream and run
No.
away. Omicron. Except this is not the disease. It is
good.
Omicron Eridani to Omicron 2 Eridani. It is a lovely triple star. The brightest star in it is pretty bright. It's actually faintly visible to the unaided eye. The secondary is a white dwarf star, and the tertiary is a red dwarf star that can be seen. So they're about 4th magnitude, 9th magnitude, and 11th magnitude. Having a little trouble catching them, but they are pretty easy to see in the sky, and I highly recommend them. And the sun is a little less active than it has been. And I know Terry's been reporting a lot of auroras up where she is, but the sun's taking a little bit of a holiday this week. And let's hope it comes back next week. And that's
Right.
about it.
Okay. All right. That's great. That's good. David, thanks so much again. So, well, up next, we will bring on Terry Mann. She is secretary of the Astronomical League, former two-term president of the Astronomical League. And she's someone that has devoted her whole life to understanding the sky and making that part of her, not only part of her own life, but she shares it with who knows how many, thousands and thousands of people. And she's someone that has been a big inspiration to me as well. And so, I always love her take on what she understands about the sky and about the community of amateur astronomers. And I love to hear her stories of sometimes, the battles of trying to get more people to understand, why science is important, why it's important to protect our dark skies, what it takes to really appreciate the beauty of the sky, and so Terry's out there doing that right now. She's kind of this adventurer type of person as well. And so she's in Alaska photographing aurora, which is something I think that she does every year. And so we are really pleased to have her on tonight. Terry, you want to come on and tell us what's going on with the Astronomical League and to do the door prizes?
Sure. Well, how are you, Scott? It's been a while since I've talked to you.
Okay. Like maybe 30 or 40 minutes, something like that, right?
Maybe so. Right. I think even yesterday. So yeah.
So the backstory on that is Terry called me up and said, Scott, I think I'm going to be late. I'm out here in Timbuktu, Alaska. And I said, well, what are you going to be about? What, a couple hours out? And she says, no, about an hour 40. I think that she probably put her car into supersonic speed because she was online with us like in 20 minutes or something. It was amazing. So, yeah.
You know how they always say when you go somewhere, it takes forever to get there, but when you're coming home, it goes by so fast.
Well, especially when you're breaking the speed limit or the sound barrier, right?
Yeah, well, no. There's too much ice here.
I'm kidding. Anyways,
watching me. No, it's I tell you, up here it has been really interesting because even though I know some people up here, but the people I have ran into, I spent a couple days at Chena Hot Springs, and the people out there when the aurora would come out, and right now, as David said, the sun is not real active, but up here it doesn't take a whole lot. And you might not get really beautiful coronal type aurora, but you still have that green that kind of moves around a little bit. So I've been here about a week and I've had aurora almost, I think, every night but one. Nothing, real bright or anything because the sun is quiet. But the people that I have ran into and just sharing stories and talking astronomy has been amazing. It's like I was saying to Scott, our astronomical community has definitely grown because there's a lot of people that are out there that are just beginning, and they have a lot of questions, and they want to know about a lot of imaging. Gary Palmer will be a great example of imaging processing. You know, so many questions right now because we have so many new people. So this is a great place to be. I'm going to be moving out of here in a couple of days and heading up another direction just to try to get a better view. And I'm hoping the sun actually gets active too. They keep saying maybe on the 24th, we might have a little bit of a brush of a CME. And at that time, I should be up higher and where I might have a better view. I'm in the woods right now. So, but it's been interesting. It's been a lot of fun. And the league has honestly been up to a lot of really good things that are moving forward. We are totally redesigning the website. And as you would expect, you always have a time frame, and it has been pushed back and pushed back, but it's because we want to do this right. We want to get everything done just right so people can tune into our website, find what they want easily. There's so much information on there. It is amazing, especially when you consider all of our observed programs. We have a ton of them. And to be able to go in and search, like I have a couple of certificates. Well, I couldn't remember what year I got them or when I got them. You can actually go on the league website, and if you have earned a certificate, you can search that and you can see what year it was. You can get the information. And so they are really fine-tuning this, so it's very simple for people to do. So we have a lot of stuff, honestly, going on. We will be live in Albuquerque, July 28th through the 30th. So please join us in Albuquerque. You can meet everybody. Scott should be there too. We'll be doing partial broadcasting from Albuquerque, a little bit of broadcasting, some interviewing with some people. So there'll be a lot going on this year. We're finally able to get out and move around again, you know, and we're careful, but it feels good to get out under the sky in a different area and to actually meet people in person. So a lot going on.
Right. I just posted the league's website, and I also posted the Alcon 2022
Thank you.
.org website as well. So you need to join the league, and you need to consider attending Alcon 2022 if it's at all possible for you.
Yeah, and the Alcon website is live now. You can register, I do believe, and you can reserve your hotel room. And naturally, since I said that, I can't remember which hotel it is, but it's on their website. The rooms are cheap. They're $129 a night. They got excellent rates at the hotel.
Yes.
So, you know, jump on that, get there. We'll all be there this year. So I think even David Levy might be coming up to join us or at least looking in on us and seeing what's going on.
I hope so. I really hope so. I hope to get out there with Wendy.
Yep.
We hope
and the venue is going to be at the MC Suites Hotel in Albuquerque.
Yep, $129 a night, and I think it is a little bit before and a little bit after Alcon that you can still get that rate. So please come and join us. We have the schedule is just unbelievably good. You know, we've all waited so long for this that it is so nice to have it. But excellent speakers are lined up, some good activities. So join us if you can. And Scott, I'm going to go ahead and get to the questions.
Please do.
All right. As you know, we always start up with our solar warning. If you're going to observe the sun, please make sure that you have proper filter to do that. Everybody loves to look at the sun. I mean, for me, it's part of the aurora, so I like looking and seeing what's going on in the sun. And it is an amazing star to actually look at. So always make sure you have the correct filters. If you ever have any questions, contact your local astronomy club. Or if you don't have a local astronomy club, contact the league. We can answer any questions you have, usually. But please always make sure you protect your eyes if you are viewing the sun. Sunglasses, you know, so many people have said, can I just wear like 2 pairs of sunglasses and that'll be fine? And, you know, no, you really need to have the right optical equipment to do this. So please make sure you do. So I'm going to go over the answers from March 15th. NGC 2169 is an open cluster in the constellation Orion. What shape do the stars of the clusters form? That doesn't make any sense. What shape? And it says 37. I'm going to say what shape or how many stars can you see in the cluster? Anyway,
there's a number down there.
Yeah, that does say what shape do the stars of the cluster form. And B, they form 37. They do form 37. Look at that.
Oh,
I can see
good Lord,
37.
I've never seen that before.
That is so cool. I didn't imagine to do
Now
that.
you can't unsee that.
No, now it's jumping right out at me.
Right.
So check that out. That was really cool. That was
See?
Don Nab's questions. I do believe that is really interesting.
It's like somebody scribbled 37 out there.
Yeah, I'm gonna have to check that out now. That's
Right.
really cool. Okay, so answer was 37, and that was B. Most of the planets in our solar system are named after geological features, ancient astronomers, or Greek Roman gods, and the answer is C, Greek Roman gods. And question 3, comets inhabit the outermost regions of our solar system. How fast do comets typically travel? As fast as an Indy race car. I like that. As fast as the International Space Station or near the speed of light. And it is as fast as an Indy race car. That's pretty cool. So there you have it. These are the names that we received for the answers from March 15th. And all of these will go on a door prize list. And at the beginning of each month, we announce 3 winners. So the March winners will be announced at the first April GSP. And what we do is keep all these names on an Excel list, and then we use a numbers generator, and we choose 3 of them that way. All right, questions for today, March 22nd. On March 28th, there will be a conjunction. And actually, there's quite a few conjunctions at the end of this month. What 2 planets will the moon glide by? And please send your answers to secretary@astroleague.org. Question 2, what meteor shower peaks on April 23rd? And again, please send your answers to secretary@astroleague.org. On May 15th, 16th, we're going to see a total lunar eclipse, hopefully with no clouds. What name has the media given this type of lunar eclipse? And again, please send your answers to secretary@astroleague.org. All right, and please join us April 15th for the next AL Live. It will be number 16. Scott, there's going to be a test to see if you can remember that. It will be number 16th AL Live. John Winskovich.
I fail every test, so.
Yeah, no, we try hard.
Okay.
Yes, John will be joining us to talk about the Lagrange points of the James Webb Telescope. We're also going to be talking to David Levy and Scott Naturally, Carol Orge. John will be there, I'll be there, and you never know who else might pop up there. And again, remember Alcon 2022 in Albuquerque, July 28th through the 30th. Please join us. Check out the website Scott has put in chat. And Scott, that's going to do it for me.
That's it. Tell us a little bit about the speaker, John, that's going to talk about the Lagrange points.
You would ask me that when I'm somewhere with not any of my paperwork with me.
Is he with Jay West, or is he?
No, I don't believe he is, but he is someone that has studied, and I don't know, there probably is a connection. I don't have his bio right in front of me, but he is a very interesting speaker. He has given this talk and he was recommended to the lead.
Very cool. Okay.
Yeah.
Great.
So, yeah, I look forward to hearing him, and that's on April 15th. So please join us then.
Okay. All right. So, great. Thank you, Terry.
Sure.
Up next will be David Eicher. David Eicher is the editor-in-chief of Astronomy magazine, but he, like David Levy and Terry Mann, he has spent the better part of his life educating others about astronomy. Today, and for a long time, he has been with Astronomy magazine, at first having his own magazine. I think it was called Deep Sky Monthly. Is that right?
That's right.
Okay. All right. That's good. It's great that I remembered that.
That's
Pass that test.
long forgotten astronomy periodicals for 500, Alex. Yeah.
Well, I remember actually seeing the magazine. So we had, you remember back when we had newsstands and stuff. So I did see the magazine. And then I do remember early issues or earlier issues of Astronomy magazine where it had, it looked very, the magazine looked like something that academia would read, you know, early on. So although I think the articles are always very interesting. And the magazine has evolved, both in print and online, so it's a great resource. If you go to astronomy.com now, of course you can subscribe to the magazine, but you're going to find all kinds of resources for the beginner, for advanced astronomers. You're going to see product review information. You're going to see what's up in the sky. So if you're one of these beginners that Terry Mann was just talking about, you're one of the people new to our community of astronomy, you could do no better than to subscribe to Astronomy magazine, join the Astronomical League, get involved with your club, and start looking at the sky as often as you can. So David has been sharing with us over the last more than several global star parties, the crystals and minerals that are found on planet Earth. A lot of people don't think about that. Oh, well, Earth is in space. Well, of course it is, and of course it's just one of multitudes, maybe almost infinite numbers of planets in the universe. And what a beautiful planet this place is, and how fascinating it is that, that we evolved to the point where, we could use glass, focusing it on the stars and turn it upwards to the sky to discover more about ourselves. But there's the other way too, and that's looking down. And so David's going to share that with us tonight on the minerals of calcium. So
that's right. And we had an old saying years ago around the office, Scott. Earth is a planet. Why would you want to do a story about Earth science? Well, Earth is a planet too, goes the old saying, So and of course we know through spectroscopy that chemistry is universal in the universe, and that many of these minerals that we have on Earth, there would be very similar minerals, chemical compositions on other planets throughout the galaxy and other galaxies as well. So we can, through planetary geology, get a look at our own planet and imagine what other planets out there might be like a little bit too. So I'm going to share my screen once again, and I'm going to see if I can share my show, and I'm going to start that show. And if everything goes right, you'll be seeing a slideshow with a red crystal.
Beautiful red crystal.
Excellent. So we'll talk tonight about a different class of minerals, but first we'll talk about why we're talking about this. The universe is ordered. Thomas Jefferson, who was a hero in some ways early in our country, said, "I believe in a divinely ordered universe." Centuries before that, though, Isaac Newton said, "Truth is ever to be found in the simplicity and not in the multiplicity and confusion of things." Well, the universe is ordered not by supernatural design, but by the principles of physics. As our pal Richard Dawkins likes to say, you don't need to magic things into existence here, but science tells us we can really understand what's going on here in the cosmos. Minerals demonstrate this in that their atoms are assembled in precise ways by electrochemical attractions, not by randomness or by accident, but inherent properties of the atoms that make them up and guide them into assembling in what mineralogists call a specific crystal lattice. So this is yet another class of ways of looking at minerals, ones that are principally made of calcium, which is an important element, and it's an important one for life, among other things as well. The most common, most abundant calcium dominant mineral is calcite, is calcium carbonate. It was named by Pliny the Elder in 79 AD. It comes in all sorts of colors as a common carbonate, white. I'm sorry? No, I thought maybe we had a question. White, yellow, red, orange, green, blue, brown, almost all colors of the spectrum here. And it crystallizes in the trigonal system with numerous crystal habits. And here's a crystallographic diagram of calcite. But there are many calcium-rich minerals. Some of them are in your body, and we'll talk about that in a second, right, in a moment now. But I wanted to show a few examples of what some of these are like, and we can talk a little bit about their chemistry too. And this is just how the universe likes to make up a planet. Rocks are minerals and other substances, if you will, that are thrown into a blender and randomized. But these are ordered minerals, the way the universe likes to bring atoms together. So as I said, the most common calcium-rich mineral is calcite, and you can see the, excuse me, the colorless, the glassy, sort of quartz-like appearing crystals here are calcite, along with a yellowish mineral called stellarite. That's another calcite mineral. Also, as a general comment here, I was kind of paring back the commentary, the labeling on this stuff, figuring it wasn't of great specific interest to everyone, but people started asking me, can you put the sizes and the specific locations on these things? Why are you doing that? So I've given the full mineralogical labels now starting tonight. On mineralogists are very interested, as you can imagine, in exactly where a specimen comes from, sort of in our world, like precisely which galaxy are you talking about, or which planet. And also the long axis, the diameter of the specimens is given there as well in centimeters. This is another somewhat unusual calcite mineral, this one, calcium mineral, sorry, xenotlite, calcium silicate hydroxide. This is an Italian specimen, and you can see there are these fibrous radial crystal aggregates of this calcium mineral here. So they're although calcium is the predominant element here, the most important of a number in some of these, you can see that you get all sorts of different looks with calcium minerals for a variety of reasons. This is a mineral called lawsonite, and it's chrome rich, which gives it a little bit of a green color here, emerald green color from chromium atoms that are in there as well. But it's basically calcium aluminum silicate hydroxide hydrate. And it's a fairly good sized specimen here from the Cyclades in Greece. And help me, I can't see everything, Scott, here because I have enough things going on my screen. But if there are questions that come up here, let me know if you would.
Well, I have a question.
Yes, sir.
Lawsonite named after someone named Lawson?
It is. It was named after Lawson, who was a mineralogist, and I don't remember the details on him. It was a fairly obscure guy compared to many of the names,
Right.
But I can check that. But most all minerals, although early ones, of course, were named after very basic and fairly primitive things. Minerals named in the last 200 or 300 years are chiefly named after people. And of course, the species that have been discovered, there are more than 5,000 mineral species that are known on Earth now. And the majority of those have been discovered in the last couple hundred years. So many, many, many minerals are named after people specifically, and many of them chemists and mineralogists, of course.
Very cool.
Here's another one here, danburite, calcium borosilicate, and this is a sort of a glassy, transparent, big crystal here with some other stuff stuck on it. And this comes from a fairly famous site that's the best site for danburite in the world, called Charcas in Mexico, San Luis Potosi, Mexico. And that is, you can see there just some very, very different appearances of all of these calcium minerals. Now, does anyone know why fluorapatite or apatite, the mineral apatite, apatite, is really important to us? And especially a variety of apatite that's called hydroxyl apatite, that's close to this composition, but a little bit different. It's because our teeth are made mostly of hydroxyl apatite, which is the hardest substance in our bodies. And also a good deal of the bone tissue in us is made from apatite minerals as well. So we're partially made of this apatite stuff, our own bodies, that is, of course, recycled atoms from the deaths of low mass and in some cases high mass stars. This is a gemmy kind of yellow-green crystal of fluorapatite here from a very well-known area in Morocco, where a lot of mining has gone on in recent times. Now here's minerals get complicated sometimes chemically, and this is an unusual one. These kind of deep lemon yellow orangey crystals called sturmanite. This is calcium, iron, aluminum, manganese, sulfate, tetrahydroxoborate hydroxide hydrate. So there's quite a mouthful chemically. I put the translations in here rather than the formulae, but that is a blender full of elements and chemicals going on here to make this mineral. It's a fairly small specimen from the Kalahari region of South Africa here. But again, calcium rich. Here's another example of an apatite, a fluorapatite mineral, calcium fluorophosphate on an albite, white albite matrix. It's a fairly small, but you can see these nice kind of sky blue crystals that are little barrel-shaped crystals. This is a Brazilian piece.
Pretty. That's really pretty.
This is an interesting one, mesolite, which is sodium, calcium, aluminum silicate hydrate. And this is from one of the great mineralogical regions where there are huge numbers of what are called zeolite minerals that are often very hydrated with water molecules attached to them. And mesolite is very interesting here because it creates these long needle-like crystals, and you can see it almost looks sort of like hair almost, super, super fragile stuff from this Indian region. Here's another one from the same general area. This is a big piece called scolasite, which is calcium, aluminum, silicate hydrate, simpler. And this is not quite so fragile. This looks a little bit fragile too, glassy quartz-like looking crystals, but it's a good deal more stable. And this one, mesolite, is super fragile. And you could almost blow some of these crystals off with your wind from your mouth here. Tremolite is calcium, magnesium, iron, silicate hydroxide. That's the grass green stuff in this matrix. This is a Finnish piece, fairly significant and interesting deep color here, fairly good sized piece. This is a very unusual one here, cerebaite. Now this is a fairly rare mineral. It's calcium antimony sulfide. Antimony is, of course, one of those elements that's poisonous. You need to keep this away from your breakfast table. From Malaysia, from an unusual mine in Malaysia. And this is just sort of massive stuff. You can see these tiny, tiny reddish crystals here. This is a cool one because there's a sort of a zoo of minerals on this one piece here that are all similar chemically and related. But the neat one, these little white spheres here, which almost look like something out of the really cheap budget out of a Star Trek episode in the first couple of years. Picropharmacolite, which is calcium, magnesium, arsenate hydrate. And associated minerals, including the reddish and pinkish and purplish stuff on there with it from this same area of the Atlas Mountains in Morocco. This is an unusual piece and a fairly rare mineral. Stellarite, we saw some of it in the first shot there, and this is focusing now not on calcite, but on the stellarite, which is this bright orange stuff, calcium aluminum silicate hydrate. This is from Kazakhstan. And you can see with almost the same elements involved as some of the other ones, you can get really, really different crystal habits and colors and appearances of the minerals, even though they're similar, but different chemical compositions. Prehnite is a fairly common calcite mineral. It's calcium aluminum silicate hydroxide. This is from Namibia, the famous region of the Orongo Mountains. It's very mineralogically rich, and that's the sort of sea water green stuff in there, with some white calcite as well.
Beautiful.
This is a big crystal. This is the stuff that's fairly similar to what your teeth are made out of here, which is of course the hardest stuff in your body. This is a big 3.5 centimeter crystal of fluorapatite from Portugal. From there are several regions where there are really big crystals of this stuff that are produced. One of them is this Portuguese location, Panasqueira. More fluorapatite, the same mineral, but you can see it's contaminated by different things that color it differently and very differently sized and with a hexagonal shape here. These purplish crystals from a German location. So just to show you some of the variety that you get here. This is a rare mineral, a phosphate mineral from a famous phosphate mine in South Dakota called the Tip Top Mine. This is Montgomeryite. Yet another chemist, mineralogist, got a mineral named after him. And these are tiny little orange crystals in the matrix here. And the last one I have here is creedite, named for Creed, Colorado, not for a person in effect. Calcium sulfate aluminum fluoride hydroxide hydrate from a specific level and spot in a very famous Colorado mine in Clear Creek County called the Henderson Mine, that gives you this sort of violet creedite here that is calcium rich stuff. So you can see calcium is really the driving force in all of these minerals, and you get very different looks and colors and crystallography in all of those different kinds of specimens. And of course, that's a snapshot. There are hundreds of calcium rich minerals, and those were just a few examples to show you some of the variety. And just quickly, Scott, to mention again, when you're done having gone to the league convention and you're back home and you need something else to do later, you could also join us in Armenia, where Scott and I and others and Garrick Israelian and Brian May and others are going to put the 6th Starmus Festival on. And we will expect we think about 3,000 to 5,000 people there in Armenia for talks by astronauts and Nobel Prize winners, and some rock and roll from some well-known musicians as well. So keep your eye on Starmus. We're celebrating Mars, and you can go to starmus.com to see all the information about that science festival.
Absolutely. That's going to be great. I really can't wait to experience this myself, because, I always considered that the Starmus event was, if there is, and I've said this many times, if there is a Burning Man of astronomy, this is it. So probably won't be a lot of people in strange outfits and on skates or something, but
no, these people will
who knows?
These people will be behaving themselves at Starmus, but it's a place where you can get close to and you can chat up, astronauts, and, really important astronomers and other scientists from other sciences as well. And you get to see some pretty good music during the week there at Starmus as well. We should have Brian May and Rick Wakeman and Brian Eno, and perhaps we'll get Steve Vai and Peter Gabriel and some others as well to be there.
Yeah, it's going to be great. I can't wait. So, okay. Well, thank you so much, David. And, I do like to point out that that you too can be a subscriber to Astronomy Magazine, just simply by going to astronomy.com. I almost don't have to write that down. It's such a great URL. But you know, if you have a tablet or something, you want to see current issues, past issues, you can get that subscription digitally. Of course, if you like to have something you can hold in your hand that doesn't require any batteries, okay, there is still a great print issues that are distributed. So, but nevertheless, you should have Astronomy magazine in your arsenal because it is, I think it's the world's largest publication on astronomy, and they cover all aspects. You're not only going to see things about astronomy, but you're going to see the latest information about astronomy gear. You're going to see all the manufacturers advertising there. You know, so if you love the gear to get outfitted for your next astronomy adventure, probably should start out first with Astronomy magazine to get an overview of what's in that landscape of great gear and great events that you can be attending. So it's just such a great resource. Thank you so much, David.
Thanks, Scott.
Yeah. Okay. All right. So we're going to move on at this point. We're leaving the United States and we're going to go to the UK to visit with Gary Palmer, who's out there, hopefully with some clear skies. But he's always got, if he doesn't have clear skies, he's got great images to share with us and lots of knowledge about astrophotography. Gary, thanks for coming on.
Hi, Scott. Thanks for asking me on. Yeah, we have got clear skies and we've literally just run into, I need to flip the meridian. So literally as we were just sort of swapping over speakers, then it's just thrown up on the screen. So we'll probably come back to the live images once I've reset everything. But certainly for looking around on the stuff, solars seem to have been picking up over the last week. Another new active area coming in today. Could see that was really spurting out some stuff on the limb. You could watch that all day, and there was a nice large prominence. So I thought, keeping it nice and simple, how about we process up a two-part prominence image and put it together? Something that people are always wondering about. So if I share a screen over, go to that one, hopefully you can see that. Okay, so we start off auto stacker at 2. I've loaded one of the images in, set it up on surface. That gives you the widest area, just in case you've got lots of stack lines around the edge. You might need it when you join the two images together. Improved tracking, and then we're coming down. Normally run the noise robust somewhere around 5 on these. Depends on how close up you are to the images. And then last thing, sort of running over to this side, is selecting one of the good frames. So I've sort of been moving the slider along there just till one of the frames gets nice and stable. Once you've done that, analyze the image. It will stabilize up. It will work out the good frames and give you a graph. As I've said many a time before, ignore the graph. It's only looking at the brightness. So really your eye works better. I've had this down below 25% and had really nice images before. So once that's done, just hit on the alignment points, place APs on the grid. So I normally run at about 104, something like that. And then set up how many frames you want. So if we look here, got 2000 frames captured and we've stacked 300. Once that's done, it sends him over to Registacks, and then we can set up for the wavelets. So we're quite, let me just put that back in. There we go. We're quite distant from it in a sense, or in my terms, we're quite distant. So I normally just set up the initial layer of 1 and then just run up slider number 2 until we're happy. And if I hit do all on that, away it goes. That's it, and then we save it. And you would repeat the process for the actual prominence section. So the prominence section's imaged at a slightly higher exposure. And if we go back into that folder, we'll find the two images there. So we can now send these into Photoshop. So that's the actual prominence there. You can see it arching right over the back here, down to there. And because it is the height and quite faint, then you need to increase the exposure time. So that does make the chromosphere line pretty bright there, which means it'll need a little bit of repairing when you join these together. But we'll send this into Photoshop. So just going to send that one in. And I'm just going to get rid of these other two images because we don't need them. There we go. Okay, and then I'm going to go back, select the surface shot and send that into Photoshop. So we've got the two of them there. And what we need to do is start neatening and tidying these up. So we're going to crop these, just come in a little bit. You always get stack lines on these sort of images. And if you haven't got stack lines, this edge here will quite often be out of focus where it has had to match the different frames together. So we just crop that. And we switch back to the prominence image and do exactly the same. Crop that. Okay, so now we need to take the surface off of this image and put it onto the prominence image. And the easiest way of doing that, select the marquee tool and just very, very gently come in underneath the black area. You can expand it up if you want to, but it's quite advisable to keep your steps on this quite small. If you don't keep them small, then you end up with points and odd shapes running along the edge here. So just take a little bit of time and run right the way across. You can expand this up if you want to be really, really precise. Can enlarge the image and do this, but just for the purposes of this, we do it like that.
While you're doing that, I have a quick question.
Go on.
Have you ever had AutoStacker impose a Bayer matrix on your monochrome images and not been able to? It's been happening to mine, and I can't figure out how to not make it do that.
What format are you recording the images in?
SER.
SER. I haven't. Not that I can remember I've had that. Have you tried both versions of AutoStacker? So AutoStacker 2 and 3?
I could try 2 and see if it happens there as well.
Because I have had issues with AutoStacker 3. If it picks up on the high cloud, it can cause problems. And in the UK, we've always got high cloud. So in general, AutoStacker 3 is only used on really, really good days. It's a lot faster than AutoStacker 2, but I have found it more stable. What would be a good idea is if you can upload that one of those SER files onto Google Drive, just send me it and I'll have a look at the SER file and see what's going on.
Yeah, that'd be great. Thank you.
Yeah. So once we've marked that out, then we need to copy it. So just copy it, run over to the surface shot and paste it in. Select the move tool, and then we want to try and line it up as good as possible. Use your arrow keys on the keyboard. And as I said, because the chromosphere line's quite bright where we've had to overexpose it in a sense, you are going to find that it's a little bit more awkward to match in. You can, if you need to, use something like free transform on that and then select up the grid section. And you can just nip up the edges a little bit and just pull these in like that if they're a little bit out, just to make it look nice, and then just drop down the centers very slightly, just so it all matches right the way along. It's up to you what you do and how long you spend on this. Once you're happy, we need to crop it all. Yeah, so marquee tool again, crop the image up. Once we've done that, you've got to decide what you want to do with the surface. And that's down to each person's preference. Everybody's different on this. If I'm going to invert it to make it stand out a little bit more, and sometimes that helps when you've got a bright chromosphere line, it helps because the photosphere is or the chromosphere in a sense, and the surface shot here is very, very dark, and it's quite hard to get rid of that. Couple of things you could do is run in and use something like shadows and highlights. Yeah, that sometimes brightens the line, but as you saw there, it darkened it. So you will have to play around, but quite often I would use shadows and highlights on these. The other way around it is to invert it. So we could try that. There we go. And then use a curve on it, just to balance down the edges there. So just very, very gently curve it around, just so it looks nice and uniform. Okay, once you're happy with that, next thing is to decide on whether you want to color it or whether you want to keep it mono. It's different for each person again. I'm going to color it just for the fun. So we're going to go to 8-bit mode now. And then we're going to go to grayscale. Don't flatten the image, keep the two parts separate. And then we're going to go to duotone. You can pick whatever color you want here. Yeah, literally. I run it as tritone. Always keep some black in there, otherwise you're going to have problems blending the background in. But the lighter the colors, the better it is for a mix normally. So you can literally go down the chart here and pick whatever colors you want and play around with them. But once you've picked a couple of colors, then we need to turn it back into an RGB image. So come back over into mode, RGB color, same again, don't flatten, leave it as it is. And we're going to start off with the surface first. You can see your two layers here. And we're just going to run over to color balance. And then we're just going to play around with some colors, and you can pick whatever color you want. If you want to go blue, then you go blue. It's literally, it's your choice at this point. Remember, all of these images are technically false color, so it's your choice as to what you do. Adjust all three. So you want to go in on the shadows and then on the highlights. Normally the yellow is quite good on the highlights for bringing in a nice sort of orangey color. Okay, once you're happy, select the other layer and exactly the same thing again. Come into color balance and you can pick off really whatever tone you want. So we just go for something like this. And you'll find here, if the prominence is a little bit dark, the yellows in the highlights is where you can give it a bit of a kick. You can bring out the prominence a little bit more there. Okay, that's just a rough thing. It's totally down to you. So next thing, how do I sort of get rid of this red in the background? That's always a problem. You can see a little bit of a patch here. That was the high cloud today causing that. So next thing, so go to contrast, use legacy mode, and then bring the contrast up and you'll start to blend it down a little bit. There we go. Make it as angry as you want. And then we could use something like selective color and go in on the blacks. I'm being a bit harsh with this. I would spend a bit more time. I did on the one earlier. It took me quite a while to remove that hole there and play around with it. And then exactly the same on the surface shot. So go back to that, go to contrast, legacy mode, and then you can get a deep orange in it if you want. And that really makes it sort of glow off of the surface then. Sort of matches in. Once you're happy with all of this, next thing to do is a little bit sharpening. So first thing is go into filters and noise. I'm going to despeckle it because the wavelet sharpening will leave a speckling layer over it if you're not careful. And then what we would do is, once we've done that, go in and use an unsharp mask on it. You'll see there, that picks all of the detail out in the surface. If I click on that, might be a little bit harsh there, so run it about there. Select the other layer and do exactly the same thing. Back in, noise, despeckle, and then back on the unsharp mask. If you see a little bit of noise in the background there, then turn it down a little bit. Yeah. What you don't want to do is make the background too noisy. Okay, once you've got these two together, one way of flattening out that a little bit, you could go into exposure and use the offset on the prominence area there. Don't go mad with it, just go up to somewhere around 50. Something like that, and you'll start to balance this out here. You can play around with it quite a bit. You could also use the gamma correction if you want in there, see whether you can pull that down a little bit more, something like that. Okay, once you've got the two levels together, or the two sections together, and that's what you like, or you've played around enough with it, if you right click on one of the layers, flatten the image, then what we need to do is look at that line there, yeah, that's running across. So if we get the blur tool, shrink it down, and just very gently take the harsh edge off of where we've joined the two of them. Quite often, if you've not had to overexpose the prominence to get it, then you won't have to do this. You can match them in more or less perfectly. But on this particular case, if you flatten it down, it just takes your eye off of that edge. Okay, then you can run into an action, something like that. Delete your other layer first before you run that, because it will mess it up. And then we can just smooth out the image, something like that. Just let that run off. That will take out some of the speckling on the background there. And really, that's about it. Yeah, considering the high cloud, you're not really going to process much more out of the image. Probably spend a little bit more time on the color in there, just so you don't get a red haze across the edge. And apart from that, let me go back to there, because I need to stop sharing. There we go. And that's it.
Okay. Well, it's never quite just that's it. But
that was
it's
awesome.
amazing you can process all of that in such a short amount of time that you do. So I have posted a link to Gary Palmer's page. He is one of the Explorer Alliance ambassadors, and there are links to GP Astro courses and to his solar imaging page as well, which you want to check out. But if you're a beginner or someone that's familiar or advanced, but you're trying to bust through something to get to the next level, or if you're even really advanced, okay, everybody could use a coach. And Gary Palmer is one of the best coaches around for astrophotography and image processing. So I recommend that you take his courses and just kind of keep that up on a regular basis, because he's going to make you all that you can be in astrophotography. So Gary, thank you very much. Hopefully, if you want to pop in and out as the program goes along, feel free to, because I know that your telescope's going over the meridian right now.
Yeah, so we're just going to set that all up, and then that will be back on in about 5 minutes. So cool. Whenever you want, I will just message you and say that it's all up and running. Okay.
So we are going around the world at this point, down to the southern hemisphere, to Chile, to Rodrigo Zelada. Now, Rodrigo is someone else that has done a tremendous amount of outreach in his area. He works closely with educators in the public school systems down there. He loves astrophotography. He's been very successful, I think, and also inspiring his own children into exploring the night skies. But he's down there in La Serena, Chile, which is a haven for astronomers. And, up in the mountains up there is also a haven for astrotourism. But he's going to share some images with us tonight. He is the owner also of North Optics. North Optics is the big telescope dealer, retailer down in Chile. And so if you want a trusted source, you want to get started the right way, and you live down there, you definitely want to hook up with Rodrigo. So Rodrigo, I'm going to turn it over to you, man.
Hi, Scott. How are
Good to see
you?
Oh, good. We're all good.
Okay. Well, in this occasion, I share with you the recent event when I'm going with a group of friends in the north of La Serena, in the Atacama Desert, near the Copiapó city. Okay, and I share my presentation. Okay. Okay. Do you see my screen?
Yes, we do.
Okay. Okay, in Copiapó, I have a friend, is a partner with North Optics, is a great astrophotographer, is Carlos Araya, and he is a group in Copiapó called the Desierto Cósmico, and he organized the great star party for the many astrophotographers of Chile, and is the called the Finca Cósmica, is the name of this sector. Participate 8 astrophotographers, the Santiago, La Serena, and Copiapó, and put your equipment in the best skies that you see in this picture, and the sky is
In a few
a
minutes,
great
I'll come
sky,
back and walk if you want.
and this is
Okay.
some equipment, and this is the picture. Some picture take in this night. Do you see this picture?
Oh, it's beautiful.
Yes,
This
Look
is
at
la Karina.
yes, my favorite picture is a Karina. My first photo in a monochrome camera is my first photo in a great photo, and this photo for the friends is Omega Centauri.
Wow.
With the mono camera is the great detail is with the Newtonian telescope Orionuka.
Beautiful,
And
beautiful colors of stars.
yes, it's an amazing photo with QHI mono camera, monochrome. And this photo is the La Pipa Nebula in the Milky Way with a photograph lens. For this picture is for Carlos Araya, my friends, the Desierto Cósmico. This object is very strange. I don't see my friend Claudio Yoa take pictures for the unknown object. And this is amazing. This is the called globular comet with is a nebula in Centauro. This Claudio.
I've never seen this before.
Yes, it's very, and I know it. This is the catalog. I know she, Claudio tell me the Gloria comet is for the appearance of this nebula.
Rodrigo,
See,
do you know if he used some kind of filters to take that picture?
this picture is only LRGB with mono camera.
LRGB, okay.
See, the sky is very good and dark sky.
Oh, I
don't
see
use-
that he used a sharp star, maybe 2.8 field of view.
And this is not a picture for the chapter.
Bueno, el campo visual, digamos.
It's very field, but
No problem. That was to know for chasing also from here in a couple of days, maybe.
yes, I take picture with this telescope, but not in this presentation. In another presentation, I share with this telescope.
Okay.
And the team, they finished the start party, three nights, and I share with you a little video, time lapse for our friends.
Okay.
This okay. Do you see the screen?
Yes, we see it.
Yes, it's a little video and the sunset and the morning with the Milky Way.
Look how dark this is. I mean, you got stars all the way down to the horizon. It's beautiful. This part of the world is some of the darkest, driest areas that you could ever hope to observe from.
Venus.
Wow.
This is the video from a friend. Is at night is sunset, all Milky Way, and the morning is
Spectacular.
This experience is spectacular for us. 3 nights in the desert is an amazing experience in the Atacama Desert.
Wonderful. Rodrigo, it's so nice to have you back on to Global Star Party. I know you've been very, very busy, you know, and I know that you're involved in not only, I think you're back studying and improving with your research astronomy. But I had mentioned something to you earlier about an educational program that's going on in South America. Can you tell us more about your educational outreach work?
Yes, when in Chile, this week is the Astronomy Weeks. Is the occasion in the many amateur astronomer and professional astronomer is share with the public your work and your experience to the children's schools and the community. In La Serena, in Vicuña and Elqui Valley, many astro tour is this Friday is organized the inauguration for the planetarium in the Vicuña and the room, salon of the astronomy. And in Chile, in different city, this week is the weeks of the astronomy. Is many club the astronomers amateur see the start with the students, public, and person the interest in the astronomy.
You know, I was able to visit Vicuña when I visited Chile. The thing that I was left with, I think if there's a country, one country in the whole world where an astronomer or an amateur astronomer would really love to visit or even move there, because it's just amazing. The entire community is just really embraces astronomy and the science of astronomy. You see that all the way down to the youngest levels of their communities and their schools. So it was a real pleasure to visit that part of the world during the eclipse back in 2019. So I hope to make it back as soon as possible, because I just really need to spend more time under the southern Milky Way skies, and there's few places better than Chile to see that, except maybe some places in Argentina. So Maxi can tell us more about that. But I love it. I love it. And
I couldn't see it yet in the desert, or maybe in San Juan, maybe near in the border of Chile. But here, doing 40 miles from here, it's stunning to watch it, the Milky Way uprising in the east. And well, now is starting again the Milky Way season, so we're trying to be prepared.
Yes, that's right. So thank you again, Rodrigo.
Okay,
so now we're going to come back from the Southern Hemisphere. We're going to come back up to the United States to visit with Daniel and Eric from Astroworld TV. So you guys have the screen now.
Good evening, everybody.
Hey,
Welcome
everybody.
back. Yeah, we're back again. So,
Hello, guys.
how you doing, Max? What's going on? Scott, thank you for having us on again. Appreciate it.
Oh,
This is,
sure. Every time, anytime.
Hey, I mean, I'll be on all week. I don't have a life, so it's okay. I could be on whatever. You know, so
This is life. Yeah.
this is, and like we say on the show all the time, it's, you know, this is a lifestyle. This isn't a hobby. This is a lifestyle. It could be life changing and life break the bank and everything.
Breaking the bank is an understatement, man.
So I was lucky to grab Eric, and Eric is one of our longest running active hosts with Astroworld. But as promised, because I kept on saying I was going to do a PowerPoint because everyone's doing PowerPoint, so I figured I'd do a PowerPoint just about what Astroworld does and how it does, and what we go and what we talk about, because we do it just like we're doing now. You know, it's literally an astrophotography chat. We do it live twice a week on Wednesdays and Fridays, and now apparently Tuesdays. so yeah, so it's a lot. It's a, you know, it's a lot.
Maybe
of fun.
in the future, Astroworld network. You know, so
Hey, well,
with,
never know.
programming 24/7.
there you go. And this Friday we have a super special guest coming on this Friday. You know who that is? Who is
No.
that? Eric, you know who's coming on this Friday?
Shoot, my mind's drawing a blank right now. Don't put me on the spot like that, man. What's up?
Scott Roberts is coming
Yeah, I
on.
think
That's
it's
my
me.
favorite.
Why do you do that? This is what we do all the time.
I throw in
right.
all these little gems of like, don't worry, I get it back full fold. So
Oh yeah.
Well, I'm sure. I can only imagine what you guys do to each other and
it's
behind the scenes.
oh, we do it on camera too. So it's
Oh yeah. No one is safe on Astroworld TV. No one.
No, and you know what?
No
We're
holds
just
barred.
lucky we live all over the world for the most part, from Simon Lewis in New Zealand to Eric in the Chicago suburbs to Jason in Arizona. We got people in Wisconsin. We got people in California. So let me before I start yapping too much, let's just go over the quick PowerPoint. And Eric's going to give a little rundown on the website and what you could do on the website, and you know, how you could join us. All right. So that being said, so here we go. So Astroworld, I coined the phrase, an astrophotography community that spans the globe, and it really is. And we're looking for other people all the time to come in and join us. I know times are an issue and can be a challenge, but we're looking to gain other people and start doing it to join us as much or as little as you want. So why Astroworld? The main reason with Astroworld, and Eric, you know, feel free to hit me up if I'm wrong, but we want to help people. We're not perfect, we're not great, but you know, we have a lot of people, multiple hosts with different rigs and different things that can answer questions live on the show. Everybody knows that when you have an issue on astrophotography, you want that answer now, right, Eric?
Exactly. Exactly.
You know, oh, went too fast. Sorry. But yeah, it's you know, it's definitely definitely can be an issue. And you know, why not just come out, hang out with everybody on Wednesday or Friday when it's cloudy and you're doing your dark frames. So you know, you could do that. And yeah, we also like to have fun on the show, as we could tell. You know, we like to have fun here. We like to have fun everywhere. So. Originally, some of our long-term watchers may remember this. It started as Cosmic Charlie and Declination Dan in 2019. With we had thanks. Yeah. Hey, listen, you know, it was Cosmic.
That's good. It was fine.
so it was, you know, it was under the studio we called it CCD squared. And it was like a double meaning type thing, you know, Cosmic Charlie, Declination Dan, CCD squared, plus CCD cameras, which is what I had. So that's how that started. After that, we threw out some videos, some really bad ones. After this one, I told Charlie to take off the hat. So this is how we evolved. We evolved from that blue sheet is his couch behind us, and I still have these shirts to this day. But we did some stuff like this, you know, way back in 2019, and then we partnered with the Backyard Astro Imaging Club for a short time, and Tim Cowell and I were doing shows for about a year, and then we picked up Eric.
Yeah, then I came along because Tim, you know, being in the UK and the way that, you know, the show was going, poor Tim, it was so early in the morning for him. The poor man couldn't even get any sleep. Yeah. All right. So, you know, when I came on a couple years ago, for me, this whole thing has been life-changing. I mean, it really, really has. I have made some incredible friends. I've met some incredible people. And to Dan's point, this is a community. I consider this almost like an online astronomy club.
It is.
And that's exactly what it is. It is an online astronomy club where we get together every week, and no question is too dumb. No, you know, or anything like that. You know, no question is out of bounds when it comes to astrophotography, because guys, we have all been there. You know, we've all been there, and we all have to start somewhere. So when I got into Astroworld, you know, my main thing was being new to astrophotography. I've only been with in astrophotography now. It's been about 5 years. I got started around 2017. And I really didn't, you know the first thing about getting started. And it's websites, and it was YouTube videos and channels like Astroworld and when it was teamed up with the Astro Backyard, you know, not Astro Backyard, but with the Backyard Club, it's like I had a place to go, and I had a place where I could meet with like-minded people, people who are, you know, experienced or novice, and we can ask these crazy questions and get honest answers,
Yeah.
you know, and get honest answers and have fun doing it too.
Absolutely.
And that's one of the reasons why I really wanted to, when Dan asked me, you know, to be a part of this, it was a no-brainer for me. It was like, why not?
Yeah.
What else do I got to do at night?
Nothing. Well, nothing in New York. Yeah, no, we're not even doing anything. I set up 3 rigs last night, and it was just cloudy. But yeah, it was horrible. I got a picture of that. But let's see. So let's see. 5, only 3 more. So now, since Eric joined on, we have 9 hosts now over the course of the 2 days.
Excellent.
Yeah, so you got myself, Scott on the top right, Eric on the bottom right, Peter Myers, and then we got Tegan, Jesse, we got Tyler, Jason, we got all these people. And believe it or not, these dates are right, Eric.
Yeah,
I looked it on YouTube.
Crazy.
We thought it was 3 years for you. It was 2 years.
Yeah, it's 2 years, but it's crazy. You know?
Yeah, it goes fast, but and you know, and then we're also on everything. So yeah.
Oh yeah.
Yeah, and
it's awesome. Awesome. You have, in effect, your own astrophotography network, you know, video network. So it's awesome. It is.
Yeah.
And how wonderful it is for the audience, because these are channels that you know, you don't have to pay for. Okay, you're getting incredible you know, knowledge from this team that, you know, that is doing it hands-on and willing to share all their information with you. You know, and you know, a great way to support them really is just by going onto their channels, liking them, subscribing to them, sharing them, you know, and helping them get a bigger audience. Because you know, I will tell you, while it's enjoyable for us to do this, okay, I love doing this as well, but it's work, and there's an investment. You have to have the right software, you have cameras to buy, you've got all this stuff to do, and you know, so it is wonderful though that we're able to engage the greater astronomical community on a global basis, you know. So really, my hat's off to both of you and to your entire team. You know, you're doing a great job.
Thank you. And if I can just do one shameless plug for our website. It's a brand new website, astroworldweb.com. And you go on there, and we have some wonderful sponsors that have come along. Am I able to share my screen here really quick, and I can show you the website?
Sure.
Okay, great. I'll just go ahead and share this, and hopefully everyone can see my screen.
Yep.
Great. So, and this astroworldweb.com, and this is the new website that was developed by one of our fellow Astroworld members, Simon, who lives in New Zealand. He made an incredible website for us, and you can meet the team, learn a little bit about us, as well as one of the cool things that we have is that we have started what we call the picture of the week, where our subscribers or members of Astroworld actually share their photos. And now we're getting to the point where at first we were judging the videos. Now we're actually putting it out into a poll for everyone to participate and give their opinion and place their votes. And what happens then is that at the end of we choose a new picture every week, and then eventually it will become one of those pictures will become the picture of the month, and then we'll end up making an Astroworld calendar that we will be able to share with everyone. Feel free to take a look at that. You can sign up. It's not, you know, you can sign up here. You can sign up on our website. You can check out the Astroworld store, which has a lot of cool merchandise. And the one thing that I will say that is so awesome about the store is that if you purchase things from the store, 5% of what you give us that goes towards Astroworld, 5% is actually given back to the Astro community, and we give back to a random astronomy club around the world. It's just a random astronomy club in the world that we will give whatever, 5% of those earnings that come from the store, we give back to the community, which I think is fantastic. And I'm just, like I said, I'm just so excited about this website. I'm excited about being with Astroworld, and it's been just a blast for me. So I really appreciate the opportunity to hang out with Dan and everybody, just, and just have a lot of fun and learn. I learned so much about, about astronomy, about astrophotography. Right now, I'm learning about IFN. I had no idea what IFN even meant.
Yep.
Integrated, flux nebulae. So,
Yep.
It's really, really cool what you can learn and, and just, enjoy yourself, so yeah, for sure.
And don't let Eric fool you. He doesn't like me.
I can't stand that guy. So I'm supposed to stop sharing it.
Yep.
Wonderful. Well, it's great to see the popularity of Astroworld grow, and you guys are doing an amazing job.
Thank you.
So you got
Appreciate
out in the audience right now, you have Sean Nielsen from Visible Dark.
Oh,
He's
yeah.
watching
Hey,
you guys. And so,
Hey, Sean.
yep, and so it's all very cool. Well, that's awesome. And what do you guys? Aside from having me on Friday, what's in your future for guests? Do you already have that planned out that far?
Oh, it's amazing.
Yeah, so basically, I believe April 6th, we have Bob Denny, who's going to be coming and giving us a rundown of alpaca. So that's going to be nice and interesting. Let me just get my calendar up real quick.
Yeah.
Because we just had Hendrik from the Star Aid. He, for those of you that haven't seen this Star Aid product, you might want to take a look at it. It's pretty awesome.
Yeah, and I know later in April we are having the great Charles Bracken.
Yep.
He's coming on.
Awesome.
Who was an author of some really awesome astrophotography books.
Yeah, the astrophotography Sky Atlas.
Yeah, Sky Atlas.
Planner,
the planner, deep sky imaging primer. So that's going to be a lot of fun having him on. We've had so many other people that have come on. I think we're having some other people coming on.
We have Colin Haig. He's going to be coming on. Then we have Chris Woodhouse, who's another author out there. We're working on getting him on. Plus, so we got a bunch of stuff going on. We've had every single one of the Masters of Pix Insight come on. We've had Sean Nielsen a number of times come on. As a matter of fact, Sean holds the Astroworld show record for longest show ever.
We just had so much fun, and we're learning so much.
It was 3 hours and 17 minutes, if I remember right. That's the longest show. That's a long show.
Yeah, we've had the opportunity to have Adam Block on twice. So he was able to teach us quite a bit and taught me quite a bit on Pix Insight. He took me to school, I'll be honest with you, when I got it.
he gave you the beat down.
Yeah, he did.
That was funny. He literally came on the show to talk to Eric.
Yeah. That was interesting.
And Scott, this will be your second time too.
Yes.
My second time. Yeah. So I'm looking forward to it. And so that's awesome. Thanks for coming on to Global Star Party and sharing the experience and the all the universe of Astroworld TV with us. So
appreciate it.
Amazing work, guys.
Thanks, Max. Have a good one.
All right. So we are going to move on to Russell Fralich from the Royal Astronomical Society of Canada. He has been deeply involved in the outreach programs for the RASC Montreal Center. And, he sent me an email today, very, very excited about his recent experience with, I think, some second graders who are learning about space from Russell. So, Russell, you're on.
Great, thank you very much, Scott. Just share the screen here. Oh, just a sec. Wrong button. There we go. There we go. How's that?
Yeah.
Good stuff.
Great.
All right. All right. Thanks again, Scott. Thanks for the opportunity. Yeah, Kareem, sorry he couldn't make it tonight. Yeah, he was talking to me about my grade 2 class experience yesterday. So we do a lot of outreach, and most of it's been, of course, delayed or postponed because of the pandemic. We did a couple of local community outreaches last year. In the winter, it's really hard to do outside because until recently, it's been around -20, -25 mostly. Today, it's very nice. It's about 32 Fahrenheit, sorry, 0 degrees Celsius. So we got an invitation for a grade 2 class, and it's frankly my first time talking to 7-year-olds since my own daughter was 7, about long time ago. So before I start, we'd like to make just a quick promo here. Kareem would have done it if you were able to join us tonight. It's Earth Hour coming this Saturday at 7 to 8:30 p.m. Eastern Daylight Time. So that's
Hey, Russell.
Yep,
we're seeing the presenter view as opposed to the full screen view.
Oh, sorry. Thanks, Molly. Just a sec. I will do the old-fashioned way. How about the low-tech way?
If you share your other screen instead of this screen, then you should grab it.
All right, I will change the screen. Thank you very much.
Yeah.
Okay, I will do this one. How about, push the button. And how's that?
We're seeing PowerPoint still, not the presenter view.
So you do not see my slide?
I see your slide.
Oh, we do see the slide.
But we also see the rest of PowerPoint.
It still works.
Oh, really? Okay, this is it.
It still works.
It's less interesting.
If you have a second monitor, then
yeah, maybe that's the problem.
So share your second monitor instead, and then when you hit the present button in PowerPoint, it'll go to the second screen.
Okay, or maybe I'll just close my second monitor. I had this problem last time, I think.
Or that works too.
Is this better?
This is fine.
We still see the presenter view somehow.
Maybe close the screen. Okay, last time.
Okay.
Last time, and then we'll move on.
All right.
Second screen. Oh, there it is. Un et deux. Je pense que c'est deux. Est-ce que ça marche? Now I don't see anything. How's that?
We do see it.
We've still got the presenter screen, but it's gonna. Oh, there it is. Yay!
Yay! Thank you, Wally. Thanks for the technical support.
You're welcome.
Okay, so sorry about the delay here. So Earth Hour is coming up. Oh, I just lost there we go. This Saturday, 7 to 8:30, Montreal or New York or Atlanta time. Oh, keeps shifting around. And we have several guest speakers, Tim Doucette, Lisa Ann Fanning, and many, many more. We're going to be talking about lots of different things with the Earth Hour. Please join us if you can. There's a connection. Otherwise, if you can't see it, just go to rascmontreal.org and there's a link there. So I will continue. So I like Scott's theme for this week. What a dull universe it would be if everything in it conformed to our expectations. And I must say that my experience with the grade 2s, well, I didn't really know what my expectations were, but even if I did, they did not conform. They went way beyond. So my challenge, perhaps you have a similar challenge. So I am a teacher by profession. Actually, I'm a professor at a business school, but my youngest students are at least 20 years old. And I find them challenging.
Right.
Yep. So our instructions were, could you please spend an hour to talk about space stuff? That was the instruction. So we have 60 minutes. It's their final class of a very long school day. So that's from 3 till 4 p.m. in the afternoon. They're pretty excited. They're pretty tired. There's 30 of them. And English is not their first language. This is a French language school, and it's an English as a second language class. And they're learning words for body parts and body movement. And I was asked to, could you please include something about that in the show? And because of the restrictions still up here, we were not able to go in person, so we did it on Microsoft Teams. There was a very, very patient teacher, and he had a support teacher in the class. So that was the challenge. So what did we talk about? So my theme was how big and how far. And I thought, okay, I guess that'll be okay. And we got them moving. So I asked them how big they were, and they had these really, really great answers, and how far things were. And I tried to frame everything in terms of objects that they were familiar with, because they were throwing numbers around. Oh, it's 1,000 or it's 1,000,000, or I even got a gajillion. And I really thought, should I ask them to write that on the board?
How many zeros is that?
Exactly, that's right. Oh, and they're very funny. They're very, very cute. So first, they were super excited. I could really say the minute the word space came up, they all like perked up. It was really, really nice. And we started with Earth. I had a little board that I could draw on, and I drew them like in a little sketch. And I said, how big are you? Some said they were really big. Some said they were small. Then I asked them, how big was the classroom? And I could see it in the camera. And they said that was big. I said, what about their home? And they said that was big. So we're talking about bigger and bigger and bigger. And then I said, well, you know, we're on the Earth. And I have a little, I have a little Earth. So I pretended I was from this cartoon, Despicable Me, with a little shrink ray. So I gave them a shrink ray, and then we shrunk the Earth down to this size. So they were pretty impressed. Then the teacher said, well, they're getting a little bit fidgety. Well, they were. So I asked them to jump up and down, and they were like very excited. And I asked them, okay, so you're jumping up, so you're pretty strong, but you always come back down. Why? And the answer was unanimous. It was gravity, sir. Oh, that's great. Where does that? And then we started talking about the Earth. So this was very much improvised, as you can possibly imagine. I would measure their attention span in order of maybe 40 seconds. And after the jumping, one kid I could hear in the background screamed because one of the other kids beside him stepped on his hand. So the teacher's helper had to stop the class, and she had to flop him over her shoulder and carry him out to the nurse's office. So I didn't know astronomy was so dangerous, but they were having a great time. We talked about the sun. We talked about how big, how hot things were. The hottest thing that they would compare it to were volcanoes. They were very interested in volcanoes. And I turned it around to their oven at home, and they said that was very hot too. So, okay, it's very good. I asked them how big the sun was compared to the Earth. So they really liked this discussion. They liked that because they wanted to talk about big things. That was pretty good. We talked about the moon. They were fascinated not by the moon picture, but by the way the word was spelled. Because in French, moon is la lune, L-U-N-E, and they were fascinated by these two little O's. I think we spent 2 minutes on these O's. It was amazing. I thought they'd be interested in the craters, but nope, they liked the O's. We also talked, pardon, Scott?
Round like the moon.
It was round. No, they liked it because it looked like little eyes looking back at them from space. I was like, really? I never would have thought of that. So they were very, very creative. We talked about distances. So I went back into my room, and I held my arms, and I asked them, the moon and the Earth, are they that far away? And they kept on going. So they really had a sense about the distances involved. I think they really appreciated it. It was farther away than their home was. So that was pretty good. Then we took a little pause while they had a little stretch, and the teacher tried to settle them down. And then he said, "Would you take some request questions?" I said, "Sure," from 7-year-olds, of course. And I had no idea what they were going to ask. So their first question was, "Sir, can you show us the planet Mercury?" Really? Okay. And then we talked about Mercury. What's the same between Mercury and the moon? And what was their answer? They both start with the letter M. Because of course they're learning English. And in French, this starts with an L and this starts with an M. And they were like fascinated. As the class went by, their ability to express themselves with we talked about body parts, how many hands, high, and those kinds of things. That it was getting a bit tougher for them to express themselves in English. So although it was a class to learn English, most of the discussion switched to French, but with the latter half of the class. And I think that was okay. We talked about Venus. They knew. So what did these kids know about the planets already without me saying anything? They knew Mercury was the closest planet to the sun, and it was very, very hot, and it had no atmosphere. So how do you guys know this stuff? They knew that Venus was special. They knew it was super hot and super poisonous. Wow, I was like pretty impressed. We talked about meteors and how many stars there are in the sky. They recognized this as a comet, and they knew that a comet was made of rock and ice. They're 7 years old. I didn't say anything yet. We talked about Mars. One kid, I said, "So class, why is Mars so reddy orange? It's a different color than the other planets." And one boy stood up and confidently said, "Sir, because it's made of rock that's made of iron, and there used to be water flowing on Mars, and it's gone now, and all that's left is the rock." So I said, "Wow, you know so much. Maybe you should apply for a job at NASA." And he was very, very happy. Jupiter they liked. It was big. They liked the rings. What else? Then we finished off with talking about the galaxy, our galaxy. How do you know it's there, etc. And there's a few other things. But I guess in 10 minutes, what were my expectations? Just so that I was just able to hang on, hang on for the ride, and hopefully stir up some interest, some of their curiosity. But I didn't really have to do much, actually. They were very, very keen. At the end of the class, the teacher said, "Thank you very much, we're finished." And pretty much all the students insisted on staying in the classroom. They came up to the camera to look at me and show me their book about astronomy. Each of them had brought a book about astronomy, and they wanted to show it to me. So that was really, really cool. They were pointing to their favorite page or their favorite picture. So that was very inspiring. The kids were great. They have so much energy. I have so much respect for primary school teachers after that experience. Wow, how do they keep those kids happy and focused? So just my last couple of minutes here, my last minute, just a reminder from our Earth Hour. And we'd like to see you if you can join us online. And otherwise, that's it for me. Unless there's some questions, I was pretty shocked, very happy, tired, and I'm sure I'll be doing it again very soon. Thank you.
Oh, that's great. That's great. I think that those of us who get involved in outreach like this, we do it for actually, it's kind of a selfish reason, because we get so much energy from it,
Wow.
So that's the gift of outreach in astronomy. I found an interesting website that I called attention to in the chat, but it's called the website is newastronomy.space, and it is a call for a new way to express astronomy through all the professional levels and amateur levels, anyone that wants to get involved. And they are asking for signatories on this. I just signed it myself because I really believe in the in the vision and mission of this project. And so I would definitely recommend that if you are into outreach and astronomy like Russell here is, and most of the people, in fact, all the people that are on Global Star Party, and it is the charter has signed the call for a new astronomy. You can read about it when you go to the website. So.
Oh, great. Thank you, Scott. I just have one last thing for
Sure.
our friends overseas in New Zealand. I found my old Dark Sky Project shirt from Lake Tekafo, which I went to visit a couple of years ago, pre-pandemic, and I'm looking forward to going back soon. Thank you.
Awesome. Yeah, I love the shirt. It's cool.
Yeah, that's great.
All right.
Thanks, Scott.
Thank you so much. Thank you. Okay, so let's check in quickly with Gary before we switch over to Molly Wakeling. I'd like to see if Gary's got anything live he can share for a couple of minutes with us.
Hi, Scott. Yeah, we've got M81, M82 up at the moment. So just doing some test imaging, really.
Okay.
Let me share that over. There we go. It's just nice, straightforward, simple 5-minute test shots.
Yeah, real wide field.
Yeah, it's on a wide field rig at the moment, a ASCAR FRA 500 with a 2600 color camera. So it's just literally doing some wide field shots, just testing it out, seeing what the field of view is like. I've just been to get a cup of coffee and I can see the sky lightening over the mountain where the moon's rising. So we won't be doing this one for much longer. Switch over to one of the other cameras. But this is a lot of really what I do is the scopes come in, we're just setting them up, different cameras, different fields of view. We'll run it for a couple of hours and then move off to something else. There'll be some other scope or some other equipment on tomorrow night. So it's quite nice sometimes if you actually get a couple of weeks where it goes quiet and you can do some imaging for yourself and concentrate on something quite nice. But
very nice. Very nice.
With the winter we've had, haven't really had that option at the moment. So
I like the way that M81 and M82 are kind of positioned in the sky. Just seeing the image of this pair, it really sums up the feeling of looking millions of light years into space, and to see the amazing wonder of what galaxies are. I mean, galaxies are the whole reason I got into amateur astronomy. I wanted to see as far back into distant space as I could, to get that, I don't know, that experience of look back time, to see back millions of years. In the case of M81, it's about 12 million light years away.
Yeah, we've got a couple of the big scopes up over there because it is galaxy season here. So I just did the first UK show Saturday. So we had all sorts of stuff going off there and then coming back and everything else. So one of those will be going on over the next day. It's actually looking clear for about a week here, which I don't know what's happening. I must be in a different zone somewhere,
Amazing for the UK. Yeah, I know it's often cloudy. So
I must
thank you, Gary. Thank you.
Sleeping and dreaming at the moment.
Right. Okay, so Molly Wakeling is back with us, and she's often on Global Star Party, but she's been very, very busy, and so we're real fortunate to have her on tonight. I have had some conversations with Molly over the last couple of years. I met her at the Advanced Imaging Conference, and find her to be, really fascinating in her interest in not only astrophotography but the science around what she images. So, and she's kind of formalized all that with her AstronoMolly programs. So we're going to let you have the screen here, Molly. Also, I wanted to point out that Molly was the winner of the Wilhelmina Fleming imaging Enriching Award. That is, it's the first astrophotography award specifically for women in astronomy. So congratulations.
Thank you, Scott. Yeah, I'm not on too often. I'm working on my PhD, and that requires a lot of energy and a lot of time.
Yes.
So I come on when I can, but I'm on spring break this week. So I finally put together a talk. Sorry, let me mute my phone. I finally put together a talk that I told Scott like must have been like 2 months ago now, something like that. We were talking about. I was at a presentation on nebula, a nebula one night, and someone was asking if we'd be able to see if we'd be able to see the nebula if we were up closer to it. So I decided to go ahead and answer that question with math.
Okay.
So let me get my PowerPoint started here and share my screen. There's the button. Okay. Yeah. So and it's something I've wondered about too, and a lot of people have asked me about at outreach events. So I decided to go ahead and finally do the math and see what the answer to that question was. All right, so I decided to do the Orion Nebula because of its popularity and its brightness, and it gives kind of a like if I wanted to go look at a nebula up close, it'd probably be this one. So I decided to use the Orion Nebula as a case study. So it's 1,344 light years away, and it's 65 by 60 arc minutes in size, so about 1.1 degrees squared. I rounded off to 1 degree for the sake of all this math. It has an apparent magnitude of +4 and a peak surface brightness at the core of 17 magnitudes per arc second squared, and we're going to come back to that. All right, so here's our scenario. We're in a spaceship. On the last ship in particular, it was the last slide, it was the Enterprise.
Right.
So we're on a spaceship, and we're going to fly by the Orion Nebula at about a distance of 1 light year, which in astronomical terms is quite close. So how big, for our first question is, how big would that nebula appear on our sky? So we have our basic picture of the observer looking at the Orion Nebula at some distance d, and it's going to subtend some angle from Earth. We see it subtending it's one square degree, so it's like 1 degree by 1 degree, and from that we can do a little trigonometry to figure out what the size in light years is of the Orion Nebula. So remember our good buddy sine, cosine, and tangent from high school. And if you recall one of the many mnemonics for remembering whether it's opposite, adjacent, or hypotenuse that goes into that fraction there. For tangent, it is adjacent or opposite over adjacent. So we have our x over d. So the width of the nebula in this case is what we're looking for. We're looking for that size in light years, and d is our distance from the target. And then theta is that angle that it subtends on the sky, so 1 degree. This case, it subtends one degree, but in order to do the trigonometry, we have to cut that in half. So we're using half of theta and half of the value we're looking for at x here is we're going to get the half of that value, and then we'll multiply by 2 to get the full length of it. So plugging in some numbers, we have, if you rearrange this equation, we get d, the distance times the tangent of theta over 2 equals the size of the Orion Nebula divided by 2, which once you plug in the numbers, gets us down to 11 light years is the half width, making the full width of the Orion Nebula 22 light years, which is pretty close to the actual value. I've done, did some rounding off with the actual size of it and the distance and whatnot. All right, now, what if we took the Orion Nebula and we changed our distance from 1,344 light years to 1 light year? How big is this angle theta? How much sky will it subtend at 1 light year? So we just have to rearrange that equation again so that we get theta over 2, so the half angle equals the inverse tangent or the arctangent, excuse me, of half of that width divided by the arc distance. So plugging in those numbers, we get the half angle of 84.8 degrees, multiplying that by 2. It's covering 170 degrees of our apparent field of view when it's only a light year away, which is almost half the sky. So if you were looking out of a porthole on the Enterprise, it would cover floor to ceiling, everything that you can see, unless you went to the other side of the ship and looked away from it. It would just cover your whole sky on that whole one side of the ship. And this works out to be 28,764 square degrees. I'm not even going to say what that is in full moons because it's still a large number. So just go with, it's about half the sky in size, which is pretty incredible.
Yep. And the human eye can only see looking straight ahead about 120 degrees.
Yeah. So it's bigger than your field of view. You could look all around and just see the nebula. You'd have to turn your back to it in order to not look at it, basically. All right. So just to kind of illustrate what that looks like. So we're here on the Earth. My second monitor is up high, so I'm kind of looking above it. And our distance of 1,344 light years, it subtends that 1 degree angle. And if we fly a light year away from it, we are very close to it indeed, and it fills up half the sky. So just to kind of illustrate what I had on the last slide. And I don't think I need to say this, but this image is not to scale.
It's a big spaceship.
Yeah, it's a pretty big spaceship. It would be smaller than a pixel if I put it in real size. But yes, that's the illustration.
That's awesome.
All right, so you might think, okay, we're closer to it, we should be able to see a lot more of its light. However, the nebula is emitting the same amount of light, but it's now spread over a much larger area. But also, that light is diverging less because it's closer to us due to the inverse square law. So a little more math is needed to see how bright it would be if we were within 1 light year of it. So I'm going to take a quick detour to talk about what magnitudes are, because we're about to get into a lot of magnitude values in the next bit. So if you do any astronomy at all, you have come across these magnitude values for how bright things are in the sky. Like that's a magnitude 5 star, that's a magnitude 15 galaxy. So, and you may or may not have known that this is actually a reverse logarithmic scale of the actual brightness of these objects. So brighter objects have smaller values of magnitude. So for example, in our table down here, Sirius is a magnitude of -1.5. Whereas the Orion Nebula has a magnitude of +4, and there's a lot of stars out there that have magnitudes of 3, 4, 5, 6, 7, all the way up. And it's not a linear scale, but it's not like a regular base 10 logarithmic scale either. It's kind of in between. So it goes by order of this constant, squared, cubed, fourth, fifth, depending on how many magnitudes of difference there are. So one unit of magnitude brighter is the fifth root of 100, which is approximately equal to 2.512 times brighter. If it's 2 magnitudes brighter, then it's that number squared. If it's 5 magnitudes brighter, then it's that number to the 5th power, which gets back to 100. So it's a nonlinear scale, but it's also not just base 10 logarithmic either. It's like this base 2.5, this base 5th root 100 log scale. You know, I should look into the history of why that is. It's probably simple, but I'll have to think about that for next time. Yeah, so here's a table of some objects that we know and love. Venus is -4.2 at its brightest. You see it real bright and easy in the sky. Sirius is really easy to see from everywhere. The dimmest that the average person, somebody with decent vision, can see naked eye is magnitude +6.5 for like a star. And the dimmest that Hubble can see for a star is +31.5, which blows away my telescope for sure. So, okay, so that's the magnitude scale. So in order to talk about how bright the Orion Nebula is going to look at 1 light year, we need to talk about surface brightness. So the apparent magnitude of an object is actually integrated over the whole surface of that object. So a magnitude 5 star is a lot brighter than a large magnitude 5 nebula, because that star is a point source. So all of its light's concentrated in one small area, whereas that large nebula, that light is spread out over a larger area. And so even though it's magnitude 5, it could be really hard to see if that nebula is near to us and looks bigger on the sky. So surface brightness is a more useful measure of how bright something is in order to compare it to other objects. So there's a relatively simple formula for this, which is here, where S is the surface brightness in units of magnitudes per square arc second. This is the same unit of brightness that if you use a sky quality meter, that's what that's using. Little m is the apparent magnitude of the object in units of magnitude. And A is the surface area in units of arc second squared. So for example, Messier 33 has a apparent magnitude of 5.79. And Messier 57, the ring nebula, has an apparent magnitude of 8.8. However, if you ever looked at these objects in a telescope, you can know that the ring nebula is a lot easier to see than M33 is. In fact, it can be pretty hard to actually see M33 from light pollution, whereas M57, you can see it almost anywhere. And that's because of their surface brightnesses. Messier 33 is much, much larger on our sky and physically than the ring nebula. It's 62 by 37 arc minutes compared to the ring nebula's 1.4 by 1.1 arc minutes. So the surface brightness of M33 is 23 magnitudes per arc second squared, whereas the surface brightness of the ring nebula is 15 magnitudes per arc second squared. And if you recall, as we just talked about with magnitudes, a larger number is less bright. So 23 is a lot dimmer than 15 on our magnitude scale. So that's why even though M33 has a higher apparent magnitude, it's actually dimmer than the ring nebula when you go to look at it in the telescope. All right, so if we want to get to, if we want to find out what the surface brightness of the Orion Nebula would be at 1 light year, we need to calculate its what its apparent magnitude would be at 1 light year. So first we start with the absolute magnitude so that we can convert from our 1300 light years down to 1 light year. And for this, we're going to use the distance modulus formula. This includes, capital M is what we're solving for here, which is the absolute magnitude, which is actually the apparent magnitude at 10 parsecs, because there's really no absolute magnitude unless you talk about the total amount of luminosity being emitted by the object. And that's another unit that is used elsewhere, but is less useful for us as earthbound astronomers. Lowercase m is the apparent magnitude, and d is the distance in units of parsecs, where 1 parsec is 3.26 light years. So if we plug in the numbers that we have for the Orion Nebula, we know that its apparent magnitude is 4. We plug in the distance in parsecs, and we get an absolute magnitude of about negative 4. Now, that's its magnitude at 10 parsecs. So how does that convert to what its apparent magnitude is at 1 light year? So we just rearrange that distance modulus formula and plug it back in for a distance of 1 light year instead of 1300 light years. We plug in the absolute magnitude, and this value here, this 0.307 parsecs, that's how long a light year is. And we get that its apparent magnitude at 1 light year is negative 9.588 magnitudes, which sounds really bright, brighter than Venus, almost as bright as the full moon. But there's a catch. That light is spread out over 28,764 square degrees. So it's not going to look as bright as a magnitude -9 star if there was one. That light is spread out over a large area. So what is its surface brightness then? We can go back to the equation that I had on the surface brightness slide and plug in our new values. Our area, this is the square degrees that it subtends when we're a light year away from it. Convert that to arc seconds squared. Plug it into our surface brightness formula, and we get 19.34 magnitudes per arc second squared, which is pretty dim. Compared to light pollution, if you live in like a suburban area, you get about 18.5 to 19 magnitudes per arc second squared. So it's about as bright as the light pollution in your area. And this average value is actually dimmer than the core of M42 at its current distance, which is 17 magnitudes per arc second squared. Now, once I got through all this math, I looked at the numbers and was like, man, those numbers are almost the same. Well, that's because they are. Surface brightness is independent of the distance. So we didn't have to actually do all that math because somebody else has done it before us to figure out what the surface brightness of Orion is. But if we don't have that number handy, this is how you can calculate the surface brightness of an object. And once you figure out the surface brightness of where it's located, whatever distance away, you don't have to calculate it for any other distance because it's going to be the same. And the reason for that is I jumped ahead a little bit, my fourth bullet point, the radiative flux, so like the photons per second, decreases with the square of the distance, but the angle subtended by the object also decreases with the square of the distance. So the two cancel each other out. So whether the Orion Nebula is 1 light year away or 1,300 light years away, it's going to have between 17 and 21 magnitudes per arc second squared surface brightness, depending on what part of it you're looking at. Now, when I was doing research for this, a guy, Roger Clark, actually measured the surface brightness of the Orion Nebula and measured it across the surface, a line in his image, and showed the surface brightnesses of different parts of the nebula. So the trapezium, we all know, is the brightest part. And so that gets up to 14 magnitudes per square arc second. And the dimmer bits get down into 19 and 20. So what would this look like if we were a light year away? You could see the glow dimly, just like you can from the ground. If even in a fairly light polluted area, you can see kind of the core of the Orion Nebula if you know where to look, except that would be all over the whole sky as opposed to being in that one spot. However, the stars would be a lot brighter. And that's because they're pretty much always point sources until you get very close to them. So the brightest trapezium star, Theta 1 Orionis, is from our distance, apparent magnitude 5.1. At 1 light year, doing the same math, it would be magnitude negative 10.5. So as bright as the full moon, if the full moon were a point instead of a surface area. So brighter than Venus, basically, by quite a lot. And the other trapezium stars would be, so they'd be very bright stars that actually would probably cause a lot of light pollution from those stars. And of course, I average this over the whole nebula. So there are some knots and filaments that are brighter than this. And for instance, the trapezium region gets up to 14 magnitudes per square arc second. So you'd have kind of a patch of sky that's actually relatively bright compared to the rest of the sky. You would notice it being a brighter glow. Probably not enough to see color still. I didn't look into that question, but yeah, you would kind of see this dim diffuse glow over an entire half of the sky, and a lot of the stars in the Orion Nebula would be much, much brighter than they are from here.
It would be bright enough to cast a shadow, for sure.
Yeah, the stars would, absolutely, yeah.
Yes, and you might be able to read an astronomy magazine by the light of trapezium stars.
Potentially, yeah.
Yes.
Yeah, it's if you've ever been out to a dark sky site and have had your night vision kind of ruined by Jupiter,
yes,
it's Jupiter is not that bright compared to this to negative 10. So it would definitely ruin your night vision to look in that direction. So yeah, are there any questions in the chat?
I think people are blown away by the math, but love the whole concept of figuring out what it might visually look like through your process. So I think that's totally cool. we can see how brilliant you are, Molly. So
Well, the
thank
math,
you.
the math is just a little bit of algebra and one trigonometry equation. It's not so bad. There's no calculus in this, don't worry.
Right. Very cool. I really appreciate it, Molly. Thank you for coming on to Global Star Party.
Yeah, you're
Thanks
welcome.
again. Okay. So folks, we're going to take a 10-minute break, and then we're going to come back with Marcelo Souza down in Brazil, and then we'll check back in with Gary Palmer and see what's going on in the UK skies. Okay, so give us 10 minutes.
Vou entrar agora.
Não, apaga o I lá aqui, ó. Bota o I aqui. Tá? Ia. Olha. Gelo. É gelo. Botou gelar. É gelo.
Well, I hope you guys enjoyed that 10-minute break. We are back with Dr. Marcelo Souza, who doesn't like to be called doctor. So, and I can understand that. So I think I embarrass him sometimes by that. But he is a cosmologist. He is a professor of astronomy, physics, and he is probably the greatest force in astronomy outreach in Brazil and known all over South America and, of course, up here in North America too. So, Marcello, thank you for coming on the show. He is, as an aside, he is also the editor of Skies Up Magazine, which is a global astronomy magazine. It's free for the download. And so I'll give a link on how to get that. But Marcello, thank you for coming on to Global Star Party.
Thank you very much, Scott, for the invitation. It's a great pleasure to be with you, Eva.
Likewise.
I'm sorry because I think that now we have different time zones. I don't know why. Now the difference between us now is 2 hours, not 3 hours. I think that something changed in your time zone.
Changed to the daylight savings time. So
maybe this because for me it changed. I don't know what, but now we have a difference of 2 hours only. Right. I remember this, and I have here something that maybe that is curious for you and the other people from the United States, because you have a Brazilian research. He already died, but he was a Brazilian. He came from a Brazilian Indian group, and he studied the constellations.
Okay.
As this group, the history of the constellation that this group saw in the sky. Then I will show how that parts of the Brazilian Indian groups, they see the constellations in the sky. It's different from the way that we make the identification of the constellation. For us, the identification is from the bright stars. We connect the bright stars and we imagine a figure here. But the Brazilian Indians, part of the Brazilian Indians, see the constellations in a different way. Then I will show you. This is I'm only showing the image of the Orion here and the Scorpius. That's it. They are the main constellation for us here, and also with the Southern Cross, because the Orion is for us is the constellation of the summer, and the Scorpius for us is constellation of the winter. And here in Brazil, all the people call these three stars here the three Marys. These three stars in the bell of Orion, everybody knows here as the three Marys. They call in Portuguese is Três Marias, three Marys that are together. Yes, three Marys. Maria, I think that is Mary in English, no? I'm saying correct.
Yeah, also Maria.
Maria also. Here in Portuguese is Três Marias. Everybody knows. They don't know the name of the constellation, but they know, because they see here for us is in zenith, in the beginning of the night during the summer. Then is near the zenith in the beginning of the summer. Then it is easy to find. Then everybody knows here in Brazil. And here are the constellations that the Brazilian Indians saw. Here is the Milky Way. And what they use as a reference here. Here is Scorpius, Centaurus, Wolf here.
Yes.
And what they use as a reference is the difference of the bright regions of the Milky Way and the dark regions of the Milky Way. Then what they see, these Brazilian groups, I need you to change it here because, okay, now yes. What they see here, here is Southern Cross.
Okay.
You have Centaurus here. What they see here? They see the constellation of Emma. That's like an avestruz. How that I say avestruz in English? I don't know. That is a big bird, a big one that you see in Australia. What is the name that you say? We have one here that you call Emma. It's like this one that you see in Australia. We call Emma here, and it is avestruz. I'm trying to find here the correct words in English to say. And here they see this bird, and the head of the bird is here in the dark region of the Southern Cross. Here is the cow bag. I don't know if it's correct in English. In Portuguese, you call saco de carvão. Ostrich, is this? I don't know if it's correct.
Emu. Emu is what it's called.
Emu.
It is called the emu. E-M-U.
Emu, yes.
Yes.
And here is the red of the emu here, near the Southern Cross, and they see here because you have a dark region here in the Southern Cross. And here, Scorpius here is part of the body of the bird here, and the alpha and beta from Centaurus are juice that the bird ate and is here in the neck of the birds. And how that this research did his work. He talked with the ancient from these Indian groups, and they show in the sky what they saw, and then he draw and show to them to know what is the correct image. This is one of them that is very famous. Is the constellation of Emma. You say Emma, no? This is another one near Taurus. It's here, Pleiades, and they see here another bird that is Tinguaçu. Is a Brazilian bird.
These constellations are huge in the sky.
Yes, yes.
Very large constellations.
But sometimes they have two constellations near. They cross between.
Oh, okay. Okay.
These are the two most famous that is on this job. Now, something that's important to us here, for us here, is to find the South Pole in the sky. This celestial South Pole here for us is very important to find, because we don't have a polar star as you have in the north. Then we use the Southern Cross as a reference for us, and also for the seasons. When we have the autumn here in number 1, the fall, in the beginning of the autumn, that is happening in this period now, you see the Southern Cross in this position in the sky.
Okay.
And in the winter, the Southern Cross is in this position in the beginning of the night. It's pointing for the south. Because here is the South Pole in the sky, the celestial South Pole. The projection of the South Pole in the sky, in the celestial sphere that you have in the sky. Here is the position of the Southern Cross in the beginning of the spring here. And in the beginning of the summer, we don't see the Southern Cross in the sky. Then this is a reference for us that comes from the Brazilian Indians. Then we know now, if I look to the sky here, I will see the Southern Cross. I see the Southern Cross in this position, in the beginning of the night. In the movement of the Southern sky, the Southern Cross is this one. The Southern Cross moves, and here is the center of the circle is the South Pole in the celestial sphere here that we imagine here, the projection of the South Pole in the sky.
Marcelo, if you were to hold your hand up, against the sky from the end star of the Southern Cross, how many hands or fingers would you hold up to find the South Pole?
I will show you. It's 4 times and a half. 4 times and a half.
4.5 times. Okay.
You measure this one.
Okay.
We call here, you have a name for each star here. It's not recognized by the International Astronomical Union, but is what we use here. The first one here, that is the bright one, we call the Magellan's star. Magellan star.
Okay.
This one here is Mimosa, in Portuguese, that we call. This one that is like orange, red, we call Rubidia. That means something like, it's like almost red, something like this.
Almost red, okay.
And this one is the Pálida. That is not so bright, it means in Portuguese. And this one, that it's don't belongs to the cross, but is here in the constellation, we call the intrometida in Portuguese. That's something that is someone that comes but don't belong to the house or something like this. and called intrometida here in Portuguese. Then to measure the distance, we do this. We use 2 fingers in our hands, and we try to, with our hand, to put this part of the Southern Cross inside.
That's 2 fingers
the
wide.
two,
right
the
there.
two, the 2 fingers here.
Okay.
And then we measure in this direction 4 times and a half.
4.5 times.
Yes. And here is the position of the South Pole in the celestial sphere, the projection. Then you go in this direction, that is the south.
Perfect. I'll remember that one.
This is what we use to find the South Pole. But most of the people here don't know how to do this. They imagine that the Southern Cross points to the south. Is what many people here think. Then when we go to schools and we make visits, we talk about this with students, but they know how to find the south using the Southern Cross. Only during the summer, that in the beginning of the night of the summer, that's not possible to use because we can't see the Southern Cross. But later, appear the Southern Cross, then they can use this. But during the winter, that's is something amazing because the Southern Cross is right in this position in the sky, in the vertical position. Then pointing directly to the south when it is in this position, the beginning of night in the winter.
That's a great lesson right there for any amateur astronomer. You know, you want to pay attention to the Southern Cross and remember what Marcelo said is that distance between the 2 stars that you see there, which is about 2 fingers wide, and then you go about 4.5 of those distances over.
We do this because I like to use a German mount for the telescopes. Then it's important to find the south, and then we use our fingers to find the position, and it works well. It works well.
Wonderful.
And here is the south. We use this with frequency here. This thing that we ever do when we go to make observations. Here is how the Southern Cross moves during the night. Today in this position, then we move, and the center of the movement is the South Pole in the celestial sphere here.
Beautiful.
Is what we do here to find. And this is something that's for the name of the constellation that the stars, Mimosa, Pálida, em português, Estrela de Magalhães, Magellan Stars, Intrometida, that I saw, and here is the Rubidia. This is a popular name, is a popular name that you use here. And here is, I want to show also that they are not near. They are very far one from another because the nearest star from us is the Rubidia, that is 88 light years from us, and the far one is the Pálida, that is 364 light years.
Quite a distance away, so it's just their line of sight.
Yes,
stars.
yes. And now we are doing activity in schools for the young stars of tomorrow. Continue doing, and now as we don't now they allow the people, students, and everybody to don't use masks here in Brazil, here in Rio de Janeiro, our state. I am still using, but it's not mandatory now. You can use if you want. You use if you want. And now we have more students participating. Now you have all the students of the school that are involved in the activities. This we organized today in a school. We have more than 100 students participating. Then at this moment, now we have big crowds of students now involved. Here are some images of this project in schools. And this week, we will launch the first cartoon animated cartoon that we are developing. It will be transmitted by a local TV here in our city. It will be the first cartoon for TV developed here in our city about astronomy and science. And here are the students participating in the project. There's something that yes, there's a lot of students now. The schools now are full of students because they return to schools, and as we don't have problems now with COVID here. We have few people in the hospitals now. You don't need to use masks, and you have more students in schools. And we are organizing also the international meeting in April 22, 23. That we are already organizing the program of the events. Everybody will be very welcome. Thank you, Scott.
Thank you so much, Marcelo. Thank you. That's
My
great.
pleasure.
Yep. All right. And have a good night. Thank you so much.
So thank you very much for the invitation.
So remember what you learned from Marcelo tonight, okay? So when you make that trip to the Southern Hemisphere, you'll be the hit of the star party, because you will know how to get those mounts polar aligned in the Southern Hemisphere. It's great. Okay, so we're going to wrap up the 87th Global Star Party with Gary Palmer. And how's it going over there? Are you still getting clear skies?
Yeah, it's still getting clear skies. The moon's risen now. So if I just share this across first off.
Sure.
It's very faint just because of the type of filter, but you can just see the Elephant's Trunk Nebula in here. That's using a color camera and one of these new dual band filters, different manufacturer this time. So it's the Antlia version, and it seems quite tight. It's about 5 nanometer filter. So when I did some imaging earlier before we came online, I'm just going to share the other screen over now. Let me just move a couple of things around. Otherwise it get a bit complicated. Let's just go back to that. And then we're going to share that. Hopefully you can see the PixInsight screen.
Yep.
And this was using the same filter earlier. So if I work out what I'm doing and stop myself getting lost, let me just close that one up a bit. There we go. So that's how it came in after it was stacked on the filter, a couple of hours, something like that. And then just a little bit of playing around with it while we're online. It's just to clean it up.
Oh, yeah.
So what it will be quite good for is taking the red out and then adding that into an RGB image. So doing this from, light polluted locations, those sorts of things. It's going to work quite well. But been finding with some of the filters, they're allowing a lot of moonlight in and different other things. And this one seems quite a bit tighter than some of the others that have been around. So yeah, quite happy with it. It's got a lot of detail in there. And if you image for a lot longer, you're going to get a lot more detail. But from the point of view here, Orion from my side is getting quite low now. It's hitting one of the mountains quite quickly. So not really going to see that till later on in the year, much more this year. So that's really about it at the moment. There's not much else sort of going on. Yeah, it's just a case of it takes time. With these sort of filters, you need a good 4 or 5 hours on a target, and then they will really brighten up. But when you're looking at them, even on 5-minute images, they're coming in quite dim for the single 5-minute image, but they're quite interesting because a lot of people use one-shot color cameras. You know,
Yes.
if you live in locations where the weather's a little bit poor, can take you hours and hours and days and weeks to gather all of the RGB data. So having these things available now, the technology that's behind this stuff is making it really interesting.
Yeah.
And just adding another edge to imaging.
Right, absolutely. You know, something I'm going to ask you about later. Have you? This is a new. We're the distributors now for Vixen here in the United States, and they plopped this down on my desk, and I'm really interested to see how this particular scope performs. So, you know, adding to our, I guess, arsenal of optical tube assemblies for astrophotography. Have you done any testing with this particular model?
Yeah, the Vixen are very good. They always have been. They've had a good reputation for years and years. They generally sort of stick to a design and they come up with something. They spend a bit of time working it all out and coming up with the designs for something, and they will stick with it for years. You know, it generally works. That's the thing. And but yeah, they can be a little bit more expensive than some others, a bit like Takahashi and those sorts of things. But you get what you pay for. You get a reliable telescope, and it lasts a long time. The image quality is normally really good.
Yeah,
we
Japanese
just
made,
one of the.
Yeah,
we've had it in for about a year and a half. One of the 100 mil quad telescopes, quad refractor.
Oh, I see.
And they're really expensive. You know, over here they're about £5,000 for one of these things. You know, they're not cheap.
Right.
But the image quality on it is very nice. You know, it doesn't matter really what camera you put on the back. There's always a nice image out of it. So I can't remember the model, but years ago they had a really big one. It was about 310 mil unit that's very similar in design to that. It was green.
I see.
About 10 years ago, I had one of those in, and that was a fantastic thing at the time. Just to run around the night sky with that, and I think it was a VCL, something like that. But anyway, yeah, I had a few of their products in. We're going to have some more in over the next few weeks.
Right.
Have a look around. Might even try and get one of those in, and we'll have a bit of fun.
So I would like to see see what you can do in imaging with something like that. So really looking forward to that.
They're really nice. They really are. Always enjoy using those. But some of their old refractors, I know a lot of people all over the world still use some of the older Vixen refractors for solar imaging.
Oh, sure.
They're so well built. You know, you can have them, they're 15, 20 years old and they're still running really well in this day and age. So,
well, Vixen is a pretty old company from like 1949 or something like that. Yeah. I get introduced to Vixen products in the early 80s. Celestron had brought in the line back then. And so I marveled initially just at the machining quality and all of that. And so I thought that their eyepieces, their camera adapters, everything was just so nicely done, so.
It is. When you screw all of their adapters together and things like that, everything's really nice and smooth, and it's what I call functional. You look at a lot of things on some of the modern stuff, and yeah, it has a use, but I don't know what it is with the Vixen. It's just everything, when you look at it, the handles, all of those sorts of things, they might not look modern, but they're functional and they all work.
Right. Yeah. So this is the handle. When I first picked this up, I mean, it's just right. It's right at the balance point, so, and I was surprised at how relatively lightweight it is. And so after,
and when you pick up some
big grains for so many years, this is very nice.
Yeah, when you pick up some of the modern stuff, while it's nice and it all works well, they are quite awkward sometimes to mount. You know, they haven't got handles on them. They're
Absolutely.
You know, I've always said this. You know, I've mounted a couple of 14 and 16-inch meads in the past, and you know, you're watching what you're doing. And I remember
there were people that messed their backs up and dropped the
we were at a
telescope.
show. I did a show for Mead in the UK about 5-6 years ago, and we had one of the big mounts there, and they sort of said to me, what are your thoughts on it? I said, yeah, it looks really nice. It's lovely. I said, it's a shame that I've got to have an Allen key to do up the saddle plate while I'm holding a 14-inch telescope. It's not a one-handed thing, you know, and it's, yeah, that's a fair point, that is. You know, but, you know, I haven't always got a friend around to hold on to something or tighten something up. And I think that's the thing, when you look at a lot of the products these days, some of the common sense has gone out of it. You know,
right? Yeah,
and that's the
so there's kind of a back to basics, you know, design that Vixen does. That is characteristic of Vixen. But I also noticed that the fit. I mean, the paint jobs are beautiful. It's, you know, every part of the machining is done very, very nicely. So, anyways, I just wanted to pull that out and show it to you because I thought for sure that you had some experience with it. That particular one has a built-in corrector to make a flat field. But I don't know yet because we're just getting the equipment now. You know, how big is the image circle? You know, those kinds of things. So maybe you have some of that old information from when.
Yeah, some of the I did find that was the only thing that was a little bit disappointing on that refractor that we had here. It was really more suited to medium format cameras.
Yeah.
And in this day, you know, but your image quality on that's going to be really sharp. You know, there's a lot of us that sort of argue, is it worth using a full frame camera on a lot of this equipment? You know, it doesn't necessarily give you the nicest image. Your stars can look, you know, quite pinpointy and things like that. So, you know, I've got one of the cameras. I don't think it's in here because we had it at the show. I mean, that's absolutely huge, you know, on the sensor. And when you put it out there, you've got a lot of other issues to run up against.
Yeah, all of a sudden.
You know, it's all right having that field of view. It's fantastic, but there's always something that gets in the way of that field of view.
Right.
On the target. So from my point of view, I like getting in quite close to things. You know, when I'm imaging things, I like to be in quite close. So I generally don't go for the full format cameras. That's for my own imaging.
Right.
But I understand that, you know, in this, there's 1,000 different types of imaging that you can do, and everybody likes something different.
That's right. And so, and that's why there's all the different equipment out there. So right.
Yeah. That's it. That's what makes it a brilliant hobby. You know, there's so many choices now that you can run off and do. That's really what it's all about. It's good fun.
Absolutely. So again, you know, I recommend that you know, if you want to learn more about your equipment, you know, especially if you're into astrophotography, you know, you should definitely hook up with Gary Palmer, take some of his classes, no matter if you're a beginner, you know, intermediate, or, you know, advanced. You know, you can get, you know, I'm sure it's you know, a joy for Gary to work with astronomers at all levels. And you know, even if you're as good as Gary is, I'm sure that you can really get into some very interesting conversations and you know, figure out ways to even get better than you were. So you know, and that's the whole goal. That's the whole goal. Gary, thanks so much. What time is it getting over there now?
It's 2 a.m.
2 a.m. Okay. All right. So
that's not bad.
9 p.m. here. That's true. That's very true. Well, thanks very much. Thanks to all the audience that watched today for a Global Star Party. We'll be back next Tuesday with the 88th Global Star Party. being that it's 88th, I think maybe I'll have to have like some sort of special door prize or something. So we'll have to figure that out. But thanks again to everyone watching around the world. And I want to thank to all the presenters that are maybe watching in the audience or watching here on Zoom. And you guys keep looking up, and we'll see you tomorrow. Take care. Good night.
You